Dear students, let us continue our discussion. In the last class, we have discussed the various aspects of stereoisomerism, that is, geometrical isomerism, optical isomerism, conformational isomerism. Geometrical isomerism is known as cis-trans isomerism also, but three scientists, Kahn, Pralog, and Ingold, three scientists, they introduced another sort of notation, EZ notation. Instead of cis-trans notation, they have used EZ notation. Z, zusammen, it means together. Engegen, that means across. Now, these three scientists introduced what is called a sequence rule. Sequence rule is based on this fact, namely, priority is given for the higher atomic number for the substituent. For example, consider one case. Any case we can choose, say D. To this carbon, hydrogen, and this is tritium. Strictly speaking, the sequence rule starts with higher atomic number. Here, carbon CH3 and H. Now let us consider. To this carbon, this group is attached through carbon, whereas here only hydrogen is attached. So, since here carbon of methyl group is directly attached, and since we know that carbon has a higher atomic number than hydrogen, this is given priority number 1, and naturally this is given priority number 2. Come to this carbon. Again, here there is a small problem in the sense, one is hydrogen, another is tritium, but both are isotopes. Isotopes means atoms of the same element, that means atoms having the same atomic number but different mass number. So, hydrogen and tritium will have the same atomic number. The question now arises is, if you say, according to the sequence rule, atomic number, higher atomic number is to be given priority, here both tritium and hydrogen will have the same atomic number 1. So, how to assign priority? If such a contingency arises, if the atomic number happens to be the same, since these are isotopes, then according to the sequence rule, you go in for higher mass number. If two isotopes are the substituents, then you go in for higher mass number. So, tritium is to be given first priority and hydrogen to be given second priority. Now, consider priority substituent 1 here, priority substituent 1 on the opposite side. Opposite side, that is across. Priority number 1 on the first carbon and priority number 1 on the second carbon. These lie across this double bond or in opposite direction. So, this particular isomer is given the notation E. Based on this, now we can see this is 1, this is also 1, this is 2, 2. So, priority number 1 together means on the same side. So, the substituents with a higher priority, they are placed on the same side together. It is known as Z isomer. You follow this. A. Bromine, iodine, halogens, fluorine, chlorine, bromine, iodine. Iodine has the higher priority, bromine the next lower priority. Similarly, chlorine higher priority, fluorine the next lower priority, and you can notice substituents having the same priority lying on the same side, so Z. Consider C. This is priority number 1, 2. This is a propyl group. Now, here also see in propyl group, that is CH2, CH2, CH3. Now consider these two substituents. Here also carbon, here also carbon. So you cannot decide the priority on the atomic number since both of them will have the same atomic number. So go in for the next set of atoms. Now here you can notice carbon is attached to 3 hydrogens, but here 2 hydrogen and 1 carbon. Here 3 hydrogens, but here 2 hydrogen and 1 carbon. And so this will have more priority than this. So C, you can notice similar priority substituents across. So this will be E. The question is, which among the following will be Z isomer? As we have seen just now, A, Z isomer, B, also Z isomer, whereas C and D are E isomers. So, if it is not possible for us to decide whether it is a cis or trans, for example, this, if you consider a general case like this, C double bond C, A, B, X, Y. If it is cis, we usually say here also I should have A, or here I should have X, both lying on the same side. Similarly, A, if Y is replaced by A, I can say it is trans. But if a situation arises in which these 4 substituents are different, A, B, X, Y, these 4 substituents are different, then we go in for the sequence rules proposed by Kahn, Pralog and Ingold. And this principle first is based on the fact that the substituents are given first priority or second priority, as the case may be, depending on the higher atomic number, if it is a group, higher atomic number of the atom which is connected to this carbon, or if it is an atom, its atomic number. So higher atomic number substituent or atom getting the first priority. The next lower atomic number is given the second priority. So first of all, which one is to be given first or second priority, you decide. And then you follow the same rules for the second carbon atom also. And as I have mentioned, if similar priority substituents, for example, take the case of B, similar priority substituents are on the same side, it is known as Z isomer, and if these substituents are across, they are in opposite direction, it is said to be E isomer. So, cis and trans isomerism or geometrical isomerism. We can also make use of this sort of notation E, Z isomers proposed by Kahn, Prolog and Ingold. Better you know about this, because at times questions are asked on this, even though in the syllabus it is mentioned that E, Z notation excluded, but at times questions are asked on this basis.